we are just going to run through, I mean, we could have done the kind of investigation and approach to it, finding an arc length and a sector area. So basically, an arc length is the length of part of the circumference of the circle. So we've got, when you cut a sector out of a circle, how many arcs do you get? 2. And what are they called? A minor and a major arc. Good. So this one here, this arc length would be the minor arc. This arc all the way around here would be the major arc. So I remember saying to you yesterday, a big part of this is just working out what fraction of the entire circle we're dealing with. And if we can work out what fraction of the entire circle we're dealing with, then we know what fraction of the circumference or what fraction of the area we're dealing with. So you can see in the formulas, look, the theta divided by 360. Well, that's what fraction of an entire circle. So that's one way of doing it. When we get to the problem solving stuff, you may be asked to use a different value to be the fraction of the circle. So for instance, if you know what the arc length is and you know what the entire circumference is, that's another way of knowing what fraction of the circle you've got. Right? But the base way is to say, right, what angle do I have out of 360 degrees? Well, that is a fraction of, multiplication means of, the formula 2 pi r is for what of a circle? Circumference, yeah? So we know that 2 pi r, or if you like, pi d, okay, is for the circumference. So c is 2 pi r, so c being the circumference. Another name for perimeter of circle. Right? And then we've got the other one here. Pi r squared is for the area of the circle. Pi r squared is the area. Okay, so both of these formulas are what fraction of, I don't know why my thing's doing this. What fraction of the circumference, what fraction of the area. So this is circumference, this is area. Something needs resetting. Okay. So that's all we're applying. Basically, that's it. Does it make sense? All right. Well, let's have a look at the first example. We're going to write down. So find the length of the arc xy in terms of pi. Now, if Steph was in the room, he'd have something to say about this question, because what does it not specify? Or how many arcs could the arc xy be? Okay? 2.
Oh, because it
Could be x to y this way, it could be x to y the other way. So we should add to this question should really minor or major. Okay? So that's what we're going to do. Maybe I'll just change the pen nib.
So are we going to solve?
So we're going to solve for both. Let's do both. Be easiest thing to do. Solve. Right. So do you know? Could you do it without me?
Maybe.
Or do you want me to do it with you? Now I've sorted my pen out. Let's see if it works. You do it?
Could we try?
Go for it. I will pause my video. Okay, the minor arc. So we know we're going to do theta over 360 times 2 pi r. Okay? So that's going to be 30 degrees out of 360 degrees, multiplied by 2, multiplied by pi, multiplied by r is 6. Okay? So however you want to do that, you chuck that straight into your calculator, or I can do 30 times 12 is what? So 30 times 12 over 360 times pi, 360 over 360 times pi equals xy. So that's 1 times pi, so pi, well it is in pi, but obviously it says give it to 2 decimal places, so the minor arc equals 3.14. Or I could say, and you're going to come up against this in another next question, or equals pi. And we've already got that. Right? So 3.14 rounded, or pi. So that's rounded. This is exact. We talked about it. What about the major arc then? So 330 over 360 times 2 times pi times 6.
Mr. Pons, in like this situation, you could rearrange it so it's 2 times 6 times pi, just so then you have.
Yeah. I'm just keeping it in terms of that, yeah. I could equally
So it could be 2r pi. It could be
2r
written
pi
down as
if you want to
2r
do it,
pi.
yeah. Just the convention is we put unknown variables after any known, so
Yeah.
2 and pi are numbers that we know.
Yeah.
But yeah, but equally we could say pi d, so then d would just be 2 lots of 6, which is 12 anyway. So you go straight to that. So we've got 330 times 12 over 360 times pi, what do we end up with?
11 pi.
11 pi?
Or 34.56.
What is it?
34.56.
34.56. Okay, centimetres, of course. Okay, by the way, what does that tell you about the entire circumference of this circle? So, just a little note.
You just like add.
Every 30 degrees you add a pi.
So the entire circumference is 12 pi in this case.
Yeah.
Yeah. Which is 12 is 2 lots of r. Yeah. Or pi d, or
So does that mean for any?
so we've shown that we should both be right.
So does that mean for any circle, it's the full circle is just going to be the diameter?
Well, what's the formula
diameter
for
of pi.
circumference? Pi d.
Yeah.
We already know that, it's in the formula,
Yeah.
but we've just shown that that's
That
what
is
we've got.
true.
Yeah? All right. How do you feel about that? Easy enough? You got it without
Yeah.
me? So the next one, find the area. Same thing.
For both?
Well,
Yeah. Which sector?
let's just do the minor sector in this case.
Would the major one be different to do?
No? What's the difference between minor and major? Just the
Just the angle.
angle. So the minor is 40 over 360. The major would just be 320 over 360. Times pi times r squared, which is 8 squared, let's say. The only real problem when people do these and answer these questions is getting the formulas the wrong way around. They don't make the link between it being a fraction of the circumference or a fraction of the area.
Pi squared.
Times.
Geometry right now.
What did you get as?
8.6.
8.77
Yeah, 'cause yeah.
units,
7773. Sorry.
but it
That is
says
3
three significant
not decimal
figures,
places.
not decimal places. So 8.77 units in this case.
Meters. What do you mean? It says
Meters. Meters squared.
Yeah, ish.
Square meters.
Square meters. My little pickiness there, but yeah. Square meters, not just meters. Alright.
So does it matter how you arrange it? Because like when you do times pi 8 squared, you get 22 point something.
That's how I had it in here. I had pi 8 squared.
And
And
you get like
then I
22.
before I put it in my
So,
calculator.
I mean, it's a very good question. What we want to try and avoid when you've got to round at the end is any rounding in between. Yeah? So, really, what I would always do is do all the numbers and leave the pi bit to the end. And quite often, especially at our level, or your level that you're working at, you're actually more likely to be asked what's the answer in terms of pi. Alright? So in terms of pi, this answer would be not 8.77, but what's all of this done? So if you can do just that bit, if you could do that as a simplified fraction, that would be good. 64 over 9.
7.1.
So 64 pi over 9 would give me an exact answer. Alright? In terms of pi, because we leave the pi there. Now really, if we put it in terms of pi, but still give it a fraction with a decimal place that we've rounded, that's pointless. Alright? So when it says in terms of pi, we try and leave it as an exact answer. Right. Normally, in an exam, if it asks for that, you're going to end up with 3 pi or something like that. But you guys can deal with that easily. So I thought we would. Here's one of the questions out of the textbook. So without doing it, it says find the length of the major arc. So this is where it's kind of trying to make you think. It's not trying particularly hard, but it does say in this case find the length of the major arc. So where's the major arc? The big one. Yeah. So we're looking for this. So what kind of understanding is that checking for? And that you don't just plug numbers into an equation, because if you were to just plug numbers in, we want to know the arc. So lots of people would get a formula booklet, for instance, and know arc length is the angle over 360 times 2 pi r, and they would just start chucking numbers in, yeah? And we've got an angle of 45 degrees, and we've got an r of 30, all sorted. But actually, when we do this major arc, we need the angle that relates to the major arc, which is 360 minus the 45, which is 350. So we need to do it with 315 degrees out of 360 times pi times the diameter is 72 in this case. I did the 2 in the other.
Yeah, 63 pi.
What did you get?
63 pi.
63.
So if it said expressed in terms of pi, that's what you would leave it as?
Yes.
Rather than pressing your SD button.
So arc length is 63 pi in terms of pi. Now it hasn't asked for it, but what is interesting here, it then says find the perimeter of the major sector. So this always leads to a bit of a mistake here. What's the perimeter of the major sector?
It's the arc length plus 2 radius, because it's not.
That's the bit that people forget. So the added bit here Alright, when we do the perimeter, we actually want all of that, which we've just worked out, and those bits as well. Okay? So the perimeter is arc plus 2 lots of r. So we've got 63 pi plus 2 times 36. So we've got 63 pi plus 72, which I could leave it like that if it was in terms of pi, or in this case we would probably now turn it into a decimal. 3 significant figures. What do we get?
270.
270 is it rounded?
3 significant figures.
269.9. So 270 centimetres to 3 significant. And now find the area of the major sector. Well, that's easy enough, isn't it? Area is just, we've already got the 315 over 360 multiplied by pi multiplied by 36 squared in this case, r squared. You. Just to, I guess we didn't record that last answer, did we? It's in the video now. Right, the last thing I want to say before I let you get on is here are the 2 formulas. So this one is for the area of the sector, this is for the arc length of the sector. It's maths, there's always a problem solving section. What are they going to ask you to do? How can they make it the same thing but slightly more difficult? Eh?
Add in a step. Like
How?
maybe, like you have to like find the angle first. Maybe.
Okay. Well, basically that's it, isn't it? With any equation, any formula of any kind, basically to make it so that the question needs to check your understanding, they can ask you to solve for other things. At the moment, this is an equation to solve for area. But if I gave you area, I could ask you to solve for the angle. If I gave you area and angle, I could ask you to solve what's the radius. All of that kind of stuff, yeah? Same here, look, I could ask you to solve using the arc length already. I could ask you to solve for the angle, solve for the radius. We could, of course, go to something like this. Checking my artistic talent. It's not Pac-Man. Not bad, is it? It is a cylinder with a chunk out of it. If I asked you for the volume of something like this,
Ooh.
Find the area of the.
yeah, you're basically just finding the area of the end, aren't you, and multiplying it by the height. So the volume of something like that would be sector area times height. Alright, so that's another way we could extend, so we can use that. But yeah, those are really the 2 things. So looking at the 2 formulas, solving for different parts, solve for the angle, solve for the radius, then start including things like 3-dimensional objects, solve for the radius of the 3-dimensional object if you're given its volume, all of that kind of stuff. So, what are you going to do? Someone's piece of work. You now are, so we've just gone through these problems. You can do the basic area and circumference of a circle. I don't think you need to. We've got the basics, quarter of a circle, you know, it's just 90, isn't it, over 360, 180 over 360, or a half a circle. These were kind of the lead-ups to understanding. So you're probably fine with going on to these questions now. Okay. into the problem solving, you can see where we've got this bit here is a sector of a circle, even though it's been chopped up. Alright, so over to you.